Hi, and welcome back to my project box. Today I'd like to look at my very old Weller Expert soldering gun. This thing is really old. It's probably from the 70s or 80s. It's that old. But, I mean, these things are fantastic. They are built like they're indestructible, basically. This thing will probably outlast me. And what makes them so great is they're basically an instant heat soldering gun. So you can solder quite heavy gauge things with them, quite heavy gauge wire, quite easily, and it only takes seconds to heat up. And it's such a simple device, and you can buy the official tips for it, but I just make my own. I literally just bend a bit of copper wire, 2.4 copper wire, 2.4 millimeter copper wire. This is twin and earth 2.4, and I strip it back, bend it into this shape, and I've got a spare soldering tip. Now granted, these don't last as long as the original because they're not coated with a special hard wearing coating. But the originals are copper as well. They just have like I think a nickel or chrome or something. I think it's a nickel coating or some sort of special coating that doesn't wear away so quickly. But if you make your own out of just normal copper wire, it's free and you can make as many as you want, even though they wear out quicker. That's exactly what I do. I make my own ones. And it's great. This keeps on going, and if I want to solder something really quickly, then I just pull this gun. It's always plugged in, pull the trigger, and within the shortest possible time it melts the solder. As you can see, it heats up super fast. It's fantastic. And yeah, so I'll show you how I make the tips, and I'll show you what's inside as well. So let's have a look on how I make these tips first. So if you want to make your own soldering iron tips for your solder gun, I would recommend at least 2.5 millimeter thickness copper wire. And it's easy to get hold of in the UK in the form of twin and earth. And all I do is I just literally just strip the earth down like that to expose the two conductors, and then I just strip the insulation off of this. I just normally stick it in the vise, and then I run a blade across it like that. And just peel it back like that. And that gives me a nice clean bit of copper. And now I simply mimic the shape of the old one. I think I'll start with the tip, make a tight bend, give it a bit of a squeeze, and I don't think this needs to be super precise. More or less. So it's not going to win any beauty contests, but there you go, new soldering iron tip. And that's it. I just make about 10 of them, and as I wear through them, that's it. I just put a new one in. And the thing is, you can do various things. You can also put a twist in it like that, and that for some reason makes it last a bit longer. It doesn't wear out so quickly. The other thing you can do as well is as you solder, it wears through, and then the copper dissolves into the solder and it just wears out. Sometimes in emergency, if it does go, you can just quickly twist it together and quickly temporarily use it again just to finish the job. So just take your pliers and do a tight twist at the end, and that'll get it going. Obviously not great, just make a new one. And then to put it in is fairly simple. You just undo these screws. There seems to be different systems on these Wellers depending on what year they were made. Now, one thing that is important is the inside of this needs to be clean so it makes good contact. And often when this thing doesn't work properly, that's normally the reason, because you need a really good connection. And it needs to be fairly tight without stripping the screws, of course. And there you go. It should heat up fairly quickly. Great. Free soldering tips for life. How great is that? Now you might be wondering how this thing works. Well, it's super simple. It's essentially just a transformer with lots of windings for the primary and just a single loop winding for the secondary. And your soldering tip forms part of that secondary winding. It's that loop where it just passes through the transformer winding once. This is that one loop. And of course, this is the thicker bit of the loop that goes through, and then the thinner bit, because it's thinner and the resistance is slightly higher, this will heat up. So it's low voltage, so from high voltage it drops down to a lower voltage, step down transformer with just a single turn for the secondary winding. And this is your shorted secondary turn. Because it's a short circuit, the part of the wire with the lowest resistance, highest resistance, will heat up slightly quicker. So let's take a look inside. Now it's bound to be very dirty inside. It's an incredibly simple device. You've got your transformer core here, which is made of a soft laminate type of steel. As you can see, this one's really rusted. I should really clean that up a bit, but you know, it doesn't affect its operation. And all it is a switch that switches the 230 volts to this primary coil that winds through this transformer coil here. So this is the mains voltage going in here, and then it gets stepped down for a single turn. Now this is a single turn. It's literally this bar going through here, coming out the back, coming through the front for your bit of copper wire. So it's one loop, just one turn. So it's a step down transformer. It's lots of turns for the 240 volt in and a single turn shorted. So it's just a loop of wire essentially shorted back on itself. And this is obviously thicker, so this won't heat up, and the thinner wire at the front, because of its higher resistance, will heat up. It's just a short circuit essentially, and that generates heat. So a simple device, really, really simple. And you have a little light bulb in the front that illuminates as well. I mean, it really is quite elegant how this is made. And you can keep on producing your own tips for this. Any sufficiently thick bit of copper wire will do the trick. And it's much cheaper than the original Weller tips for it. They don't last as long, but it's free, so you can make as many as you want. And it only takes seconds to change the tip. Now I have put a longer flex lead on it, because I like to be able to just plug in somewhere and not use an extension cord. So yes, it's very serviceable, very well made, simple little device. It's essentially a transformer like this one, and you have your primary here, and this is a step up transformer from a microwave. So this is a few turns to many turns. But if you were to remove this high voltage coil and just power this one, you can put a single loop of wire through here, shorted, have it coming out on this side, and you can have like a soldering iron that you can use that instantly heats up, that you can use to tin really heavy gauge wire you can solder together.
So it's just a thick lump of wire with a little brass rod that has a slightly lower resistance, sorry, a slightly higher resistance that will heat up quicker. So it's essentially the same thing as my soldering gun, and it heats up incredibly fast. You can start soldering within under a second. I'll demonstrate. Even when I step on the pedal, it just heats up incredibly fast. And I'll show you how quickly you can start soldering a bit of wire with it. It's just almost instantaneous. And you can solder like really heavy gauge wire. Obviously, if I had the switch on for too long, it would glow red hot and it would just destroy itself. But if I just step on it quickly, it instantly heats up. I mean, with this big fat soldering iron I just made, there's actually no limitation to what you can practically solder, no matter how many wires I twist together or how thick the gauge is. It seems to be an absolute breeze to solder it. You know, if I just turn the soldering iron on again, if I show you, this is just nothing to solder this. It did that in seconds. I mean, obviously now it's starting to overheat because it's so powerful. But yes, pretty useful. I wouldn't run it for much longer than that because it's already starting to discolor. It will melt clean through that if I put it on for any longer. So even though this was only made as a demonstration for how the soldering gun worked, it could actually be quite practical on a foot switch. And the tip stays stationary, and you can bring your heavy gauge wire or whatever you want to solder to it. And then you have your hands free to hold the wire and the solder. And this stays stationary, you just bring it towards it and then step on the foot pedal to solder. So actually, might be worth making one of these microwave oven soldering irons.
Now I have used this soldering iron when I'm lazy to solder everything from most PCB jobs, even the occasional SMD job. Now surface mount components are notoriously difficult to solder, so I don't recommend using this for that, but I have done it. I have obviously better soldering irons for the job, and also heat guns and various other ways to do SMD work. But if you watch Diode Gone Wild, he uses this for everything, and he even does surface mount devices for this with this really thick, big, clumsy tip. He manages to do them all the time, so with copious amounts of flux. Yeah, so a very handy bit of kit, something from a blast from the past. It literally is something from the 70s and 80s, but I like it, and it seems a bit old-fashioned, but I just like the speed of it. I like how you can just grab it and use it instantly without having to wait for it to heat up. I like these old boys. They're good little workhorses, and it's got me out of trouble many times. Now you can solder quite heavy-duty things with this. I mean, I'll give you an example. That's quite a heavy thermal mass. And normally, with a normal soldering iron, you would struggle to solder heavy bits of copper and brass like that together. But with this, look at that. And it only took seconds to heat up. That's quite incredible. That's why this tool is invaluable to me. You can solder straight onto a bit of metal plate, no problem. So another thing that I thought I'd mention is sometimes I use my little foot switch that I made that basically just switch a little socket outlet on and off. So you have a plug here and it just switches the live on and off. So you plug this end in, and now when you hit the foot switch, it will turn this on and off. And then I can plug my soldering iron in here, and it can be hands-free. So that way, if I have multiple wires that I want to solder, and this can stay stationary, and I can just carefully hold it here and feed the solder into it, and turn wires or make up a loom or whatever. So the soldering iron can stay stationary and nice and still. And then what I of course need to do is the switch needs to be held in, so that the foot switch does the power on and off switching and not me. So I'll show you how that works. So I'll just plug the soldering iron plug in here. And of course it's not on until you press the foot switch. So the idea is that the foot switch goes down on the floor, and now you can just step on the foot switch like I have now, and the soldering iron could almost instantly heat up, and I can just easily turn quite heavy gauge wire, and it makes it quite easy, and you can instantly just let go of the foot switch and step on it again if you want it to heat back up again. This is quite convenient actually to keep, so you don't have to hold the soldering iron in your hand, and you can just top it up at any time with the foot switch. Quite convenient. Makes for quite a neat job. And you can solder heavy gauge wire with this. You can make up looms, and it's quite handy to have this on a foot switch. It's not necessary, but it's handy. And I'll give an example if I want to solder two wires together. So I'll just twist them together. This is a 1.5 mil stranded wire, so it takes a fair bit of heat to solder this much copper. But I just step on the switch, wait a couple of seconds for it to heat up, and as you can see, I've now got hands-free. It makes it easier to solder. There you go. Let go of the foot switch, and we've got a nice connection. And also, if I want to use the heat shrink gun, I can do the same thing. I can stand the heat shrink gun up and plug it into the foot switch, and I can put heat shrink on and hold the heat shrink carefully. Or so, because sometimes when you heat shrink if you put heat shrink tubing on and you apply it, it shifts to the one side when it shrinks, and then you kind of miss what you're trying to heat shrink. So it's nice having the heat gun on the heat shrink too. I can show you that as well. So it's actually very handy to be able to put a heat gun like this on a foot switch. That way you simply take your heat shrink and you kind of slide it over, and now you can sort of guide it. Just step on the foot switch, and you can neatly shrink it on. And it means that you can have your hands free. You don't have to hold the heat gun in the one hand. Because I found what happens is sometimes the heat shrink jumps to the one side. And this way you can sort of have both hands free and focus on making a neat joint. So I thought it'd be fun to see if I could measure the current through the soldering tip. So I replaced the bit of copper wire, 2.5mm copper wire, with a loop. And of course it actually affects how long this piece of wire is and how thick it is. So if the original is slightly thicker, the current will be different. But it's a rough test, and I'm sure there has to be quite a lot of current for such a thick bit of copper wire to be able to heat so quickly to melt solder. So I've got this clamp meter here, which I can just clamp over here, and then we could see roughly what the amperage is. So if I clamp that through here, we should be able to get a reading. Contact. So that starts off at about 250 amps, and as it heats up, the amperage drops. 250 amps. That's a lot of current. That's a lot of current from just passing a single loop of wire through a transformer. It's quite amazing how transformers work. Now, be interesting to see what sort of voltage we get across from the output of this transformer when it's loaded up by this tip. I bet you it's not much. I bet you it's less than a volt. So I've got another multimeter set up for that. So let's have a look. So it's about 0.260 millivolts. 260 millivolts at 250 amps. Now it's meant to be 100 watts, but of course volts times amps roughly gives you the watts. But it very much depends on the thickness of this copper wire. and how good your connection is. Yeah, but it's interesting. Interesting. So anyway, I hope you found this video interesting, and if you guys like this video, please consider to like and subscribe, and hopefully I'll catch you on the next one. Thank you for watching my project box.
You are watching my project box. Smash that like and subscribe button.